Hi guys, we have lesson 6 on polyatomic ions here. So polyatomic, if we break that word down, poly meaning many, atomic meaning atoms. So these are a complex list of ions on your data booklet that have many different atoms in them. So if you open your data booklet to the periodic table, we have the polyatomic ions in this box right here. So you can see that these have many different atoms all put together. Like here we have nitrogen and hydrogen, iodine and oxygen, nitrogen and oxygen. So it's just some combination of multiple atoms put together to make what we call polyatomic ions. So these are still ions, they have charges, and they can combine with other metals or nonmetals to make compounds. So if we take a look at the first example, this one has NO3 in brackets. That's because NO3 is a polyatomic ion. If we find it on here, NO3 is right here. It's called nitrate. So you'll see different endings. It's not the IDE ending that you're used to seeing with naming ions. It's ATE for this one. Nitrate has a charge of -1. So when I look at this, I'm always thinking of nitrate as one thing. Even though it's many different atoms, it's one ion itself. So this group here, how many of them do we have? 2 of them. The number on the outside of the brackets is telling you that there's 2 nitrate ions. So the overall charge, if they're each -1, would be -2. That means if this is written already with the chemical formula, that these have balanced. So one iron would have to be iron 2. So naming this would be iron 2 nitrate. Try the next one. These will take some practice before you start recognizing the groups of ions. So for me, I've done a lot of these before. I recognize NH4. I know that it's on my data booklet right here as ammonium. So above NH4, I'm going to write a +1. Now it's hard to see because there's no brackets around NH4, but with chemistry, we always do the simplest form. So if I only have one ammonium ion, I'm not going to put brackets around it and put a 1. We don't put secret ones in chemistry. So this NH4, although it's all together as an ion, doesn't have brackets because there's only one of them. The nitrate that we worked with above was a charge of -1, and the more you practice, the more you'll be able to recognize that NO3 would be a polyatomic ion. And then you're just simply going to write the names in the order that you see them from the polyatomic ion chart. So the first one we had was ammonium, the second one nitrate. So together like this, they're called ammonium nitrate. Little more complicated. First, I'm going to start by looking at the polyatomic ion PO4 in brackets. This is phosphate right here, PO4, and it has a charge of -3. So now that I know one phosphate ion has a -3 charge, 2 of them would make a total of -6. Knowing that this is going to balance with a +6 helps me decide what these 3 leads will have to be. So 6 divided by 3 tells me that each lead ion is a charge of +2. That means that this is lead 2 phosphate. Now remember that we only have to write the Roman numerals if we go on the periodic table and we see that that's possible. If that wasn't possible, you wouldn't write the Roman numerals. All right, writing the formula is similar to what we've done in the past. It's all about crossing the charges so that they balance. The first example has copper 2. We know that when the Roman numeral is here, it's telling us the charge of copper is 2+. Sulfate. I'm going to look for sulfate in my polyatomic ion section, and I see it right here. Sulfate is SO4, and it has a charge of -2. So you can see that above sulfate, I wrote -2, the charge. So here we have an example where the charges are balanced. So we don't need to write any subscripts, except that sulfate already has a subscript of 4. That's fine. You're going to write it exactly how it appears right here, SO4. Notice that there's a number up high and a number down low. The number up high is the charge. You're not writing that. The number down low is part of this. This is saying that a sulfur and 4 oxygens make sulfate. You have to keep the 4. So there's my sulfate, and there's my copper. Even though it's copper 2, my charges have canceled out, so there is no subscript here. You're going to write a solid for now until we learn the solubility table. Now, ammonium sulfite. To the data booklet we go. Ammonium +1, write that above ammonium. And sulfite, careful with your endings here. We have sulfite and sulfate. You need to be careful. Sulfite is a charge of -2. So above your 2 words, you've written the charges that we just found. Now these don't balance. 1 and -2 are not balanced, so we're going to cross the charges. So the 1 is going to go behind the sulfite. Here's sulfite. There's a secret 1 behind it, but we don't write it. We also don't write the brackets because they're not necessary. However, when we cross the 2 to go with ammonium, we have multiple atoms here in our polyatomic ion. We need the 2 to apply to everything in ammonium. So this is where you put ammonium in brackets, and you put the 2 that's crossing behind it outside. So this is the full chemical formula for ammonium sulfite. NH4 in brackets, subscript 2, there's no space between these, and then SO3 solid. Next example is aluminium hydroxide. We know aluminium is just an element on the periodic table, so if we find that, we see that aluminium has a charge of 3+. Above that, write 3+. Hydroxide, that's a special name. It's a polyatomic ion found in this section. So if you look for hydroxide, it's right here. OH with a charge of -1. So you can see I've written that charge above hydroxide. I've also written what its symbol is below, just so I can keep track of what I'm writing. Now I look at the charges. 3 and 1 are not balanced, so they need to cross. The 1 is going to go behind aluminium. The 3 is behind hydroxide. And because it came from the polyatomic ion chart, it goes in brackets and the 3 goes outside. This is telling you in this entire compound that you have 3 hydrogens and 3 oxygens. So brackets are important so that the 3 applies to the oxygen as well. This is a visual representation of what's actually happening here. When we put the secret 1 behind aluminum, that means that we only have 1 aluminum ion with a charge of 3+. When we've put this 3 behind hydroxide, it means that we have 3 copies of the hydroxide ion. So 3 of these hydroxides that are each -1. In this visual representation, you can see that we have 3 positives and 1, 2, 3 negatives. That's how it balances. This is why crossing the charges works. Now there's a section in your work booklet on polyatomic ions that I'd like you to do. Make sure that you open up the data booklet and you're referencing that to get all of your charges. If you need, don't hesitate to ask.